So welcome to the second day of our workshop in Python programming and machine learning primer. So yesterday we talked about the basic Python data types, and we also looked upon the pandas and NumPy library in brief. So today I'll just start the session for today and recap what we have learned yesterday first of all. So let me share my screen. Yesterday in day one, we have learned about the basic types of Python data types like integer, string, float, list. We have looked upon it, tuple, range, all that. And also we have seen how to import data and know the data shape and all that thing. And also in NumPy library, we have looked upon. So today, our agenda for the day will be we'll look deeper into the sequential data types, which is very, very important in Python programming language. Whenever you are having any interviews in companies or anything, they will ask you what is the difference between the different sequential data types. Then we'll look into the different Python operators, and then we'll see the different Python built-in functions, and then we'll see loops. Okay, so let me start first with the comparison of the different sequential data types. So the first sequential data type is list, then tuple, dictionary, and set. So what are the differences between list, tuple, dictionary, and set? You can see here that list and tuple allows duplicate members, like duplicate elements, but dictionary and set, we cannot give duplicate elements. List is changeable, that is mutable. Tuple is not changeable, that is immutable. Dictionary is also changeable, and set is also immutable, but it can be added. Set elements can be added to set. Okay. And then list is ordered. Tuple is also ordered. We have to maintain the order of list and tuple, order of the elements in list and tuple. But in dictionary, it can be unordered, and also in set, it can be unordered. We represent list by this square bracket, tuple by round brackets, and in dictionary by curly brackets, and also set by curly brackets. So now let me show you the different functions in list. So first, I will write a comment. I will create an empty list. Okay, so empty list. And I will give it a variable, say L. L equal to square bracket. Square bracket. Then I have, this is an empty list, L. Now I want to add elements to this empty list. So I will use a function called append. So L dot append parenthesis, then I will add 5. Now there is an important point to note that in append function we can give only one argument. That means we cannot add many elements in the empty list at once with append. So if I want to give another element, I have to again write L dot append, say 7, like that. L dot append 10. Now let me see how does my list look like. So run it. I'm running it, and I think it will come out. Just a second. Yeah, so see 5, 7, 10. Now if I add all the elements at once, it will show me an error. You can see append, if I write 5, 6, 7 all at once, then when I want to see, it will give me an error. Look, it is giving me an error. Okay, what it is written here? Append takes only, sorry, append takes exactly one argument and 3 are given. Okay, so I'll just drop this column. Now I will show you other functions. Like, now I want to see how many elements are there in the list. So what will I do? I'll use a function called len. Len means length. Len. Len means length. So I will just write len of L. L is my variable here. So L. And I will print it. So I will write print len of L. So this will give me 3 elements, 5, 7, and 10. Now, suppose I want to add another element before 5. I want to add an element before 5. So what will I do? I will insert the one element in the specific index. So in list, you have to understand the indexing in list first. So in list, the indexing starts from 0. So 0, 1, 2. Now if I write L0, it will give me 5. So 0, 1, 2, 3, 4, like this extends like that. And from backwards, it's -1, -2, -3. From forward, it starts from 0, and from backward, it starts from -1. Okay, it's the list indexing. So if I now want to insert an element before 5 in the list, I will write L dot insert, say, in place of 5, I want to write another element, say. So then I'll write 0, and I will say RAM. I'll write RAM. Let it be RAM. So it will be RAM. Now let me see what does my list look like. So my list would look like something like this. RAM 57. Before RAM, I am inserting the before 5, I am inserting the RAM. Okay. Now the next function, I want to clear. I want to make the list empty again. So what will I do? I will write L dot clear, and I'll give parentheses. It will automatically clear. Okay. Now if I see my L, I will print my L. Then I'll get an empty list. Look, empty list. Okay. So now suppose I am giving another list. I'm making another list. Say list 1, and it contains the marks of different students. Let's say 24. Let's say 56, 78, 99, 32. Any random numbers I'm giving. Okay. Now I want to delete this 24 marks. It's an error. It might be an error. The student has scored more. So I want to delete this mark. So what will I do? I will just write del means delete list 1, and I'll give my index. Index is 0. It's starting from 0. 0, 1, 2, 3, 4, like that. So 24 is 0. So index is 0. So I will write this. Now, if I print the list 1, you will see it's gone. See, 56, 78, 99, 32. Okay. So next, I want to remove a specific, I don't want to give the index. I want to remove directly with the number. I want to say that this student has scored 24, but it's wrong, and I want to remove that. So how will I do? I will write list 1 dot remove square bracket, say says I want to remove 78. Remove 78, and I want to print the list. Okay. Oh. Okay. Okay, I think it works for string only. Okay, let me do one thing. I'll show you. List one dot append rough, and then list one dot remove this will work like this. Round. See? Yeah. So it's work like that. Actually, I had given the square bracket. It would be the parenthesis. Okay. In also here also I can remove the 56 number. So I can write list one dot remove. Say 56. Let's see if it works or not. Yeah, it's working. So yes, so the remove is a function. In function, while writing function, we do not use the square bracket. We always use the parenthesis. Okay. So next I want to add two lists. So let me create first two lists. List one, say I'm saying 1, 2, 3, anything 3, 4. Okay. And then list 2, I'm giving list 2 equal to say 3. Then I will write 8. Then I will write 9. And then I will just add the both. So how can I add? I can add by extend function. So what is an extend function? I will show you. List 1 dot extend list 2. Okay. And then I'll print the list 1. The elements of list 2 are getting added to the list 1. Okay. And list 1 is extended by the list 2 elements. So now if I print list 1, I will get list 1. I will get the whole thing. Yeah, see, I've gotten the whole thing. Okay. So next, I can also take the value by index. Suppose there is a list 2, list 3. 1 is 1, 2, 3, 4, 3, 8, 9. So now I want to get the element in the second position. So in the second position, what will be the index? 0, 1. 1 will be the index. So if I want to get 2, then I will write list 1 dot index 1. So and list 1 dot index 1. Yeah, it will directly give me 0. 0. Okay. 0 should not be given. Specified index should be given. Let's see one thing. Yeah, 3. Okay. So 0, 1, 2, 0, 1, 2, 1, 2, 3, 4. 4. 1, 2, 3, 4. Why is it giving? Yeah. 3, 0. 0, 1, 2, 3. 3, 4. Okay, so in the index 4, there is, it is counting from the backwards, I think. So it's 4. Okay, next code. I want to sort the like I will give one list, say one list equal to 23, 11, 42, then 31. Then I want to sort this list. Okay, list dot sort, and it will sort it in the ascending order. This is sort is a function in list. So now I'll print the list. Print the list. Print the list. Yep. So 11, 23, 31, 42. It has just arranged it in a ascending order. And if I want to reverse it, I want to get in the descending order, then I'll write reverse. So I'll just list dot reverse. Okay, and then I'll write print list. Print list. Okay, so this will be 42, 31, 23, 11. Okay, so this was list. Next, let's move on to we'll move on to tuple. So how to define a tuple? So let me create one tuple. So tuple can be, let me write it as T1, say tuple 1, and I'll give parenthesis and I'll give the elements directly. 4, 5. Okay. Now I want to see the length of tuple. So I'll add length of T1. Okay. And it will give me 5. Now so now I will take another tuple, say T2. Okay, and I will give T2 equal to say 6, 7, 8. Okay, and I want to add tuple, both the tuple. Give it a name T3. T3 equal to T1 plus T2. T2. It will give me T3 or not. Let's see. Yes. So it's just joining. Okay. So now I'll just do another thing. I will show you another function in tuple, that is count function. Okay. So suppose x is a tuple and x is equals to tuple. Let's say it contains a name. Contains a name Ram or Ram. Okay. Now then I want to see how many letters are in Ram. Okay, I want to see how many letters are in Ram. So what I'll do, I'll print count x. Let's see if it works. Okay. Name count is not defined. Count was a function. Right. Does they? Okay, I am not sure about the count function. Let's see. No, I think count function is not there anymore. So let's just drop it. Okay, so now can I get the index number of a particular element in a tuple? Let's see. Okay. So T3 dot index E3 dot index 3 of 3 element 3. Yes, so 2 0 1 2. So 2 number is 3. 3 element is in 2 number index, so it's giving me the index back. Okay. So this was about tuple. Now let's move on to the dictionaries. Okay, so dictionaries are unordered and also allows no duplicate members. They don't allow any duplicate members. So let's make an empty dictionary first. Okay, empty dictionary. Let's show you to make an empty dictionary. D equal to this one. Okay, curly bracket. In dictionary and set are defined by curly bracket. So D is equal to this. Then there are two things in a dictionary. There are keys and values. So it's a dictionary is a mapping data type where it maps one value to another value. Okay, like say I will add a value. I will show you how it maps. So say I will write 5 and I will correspondingly I have it's 5. I will write in words. Okay, and then I will write D7. D is the dictionary here. I am adding the elements here. So equal to 7. Okay. 7. And then I will print the dictionary. Okay. Let's say I want to print dictionary is this. So dictionary is now D. Let's see D. Okay. So it will print me the dictionary. I'm writing the dictionary is this, whatever the dictionary will come. Okay. So say this 5 and 7 in numeric form are the keys, and this 5 and 7 in word are the values. Okay. So now to get the let us take another dictionary and let us make another dictionary. Okay, first I will make let's make a car dictionary. Okay, car corresponding to the value. Also I will write dict. Dict means dictionary. Dict is equals to dict1, say dict. It's a variable dict1. So this one, then I will create code. Okay, I'm taking the Ford car. Then I will give a comma, and then I will add another key and value, that is model, say Mustang. Okay. And then I'll add the year in which it was launched. So year 1964. In dictionaries, we can add any kind of values. Okay, any kind of values, boolean, number, float, anything. List, we can even add list. Okay, within dictionary, so we can add anything inside the dictionary. Okay, now I want to see the I want to get the value of the key brand. Okay, then I will write print dict1 brand. Okay, I'll get the Ford then for that. Okay, so let me run it. Yeah, so Ford, I'll get Ford. So the value corresponding to the key brand is Ford. Is giving me Ford. Now I want to see what is the length of the dictionary. Suppose. Then I'll write len of print len of dict print len of dict dict. Okay. So I will print it. Let's see how it. Okay. Object of type. Len is not here in dict. Let's say. Okay, len is not in dict, I think. Okay. Dictionary has no length function, I think. So let's move on to the next next data type, that sequential data type, that is set. So how do we define a set? We define a set by also by a curly bracket. Okay, so and it is also an unordered, unchangeable, unindexed data type. No duplicates can be there in a set. Okay, so let's first form an empty set. Empty set. Set s equal to set. Let's see if it works. Yes. So s is equals to set, and then I'm just forming an empty set, and I'm then adding values in the set. When forming an empty set, we don't have to give this curly brackets. So we just give the parentheses. Okay, adding values to the set. So I'll just add s dot add 5 or 4. Okay, 4. Then I'll add s dot add 10. Okay, any value you can add. So I'll just add into the set. Okay, let's see. Okay. Now and see the how the set looks. So print s. Look, it is represented by a curly brackets here. Okay. Now I want to remove the element 4 from the set S. So what will I do? I'll just use the remove function. Okay, as dot remove. Sorry, I'm just using the hash. I don't need the hash for running the code. So just 4. Then I'll write print S. Let's see. Okay, see, earlier it was 10, 4, then I removed 4, then I'll get 10. Okay. Now see, if I want to add multiple elements to set, what can I use? I can use the update function. Okay. As dot update and update A, then I'll give mark A. Let's say. Then let's see S. What is S? Hope it runs. Otherwise, yeah. So let's see what S gives. Yeah, it is giving me a set of this. 10 was the S value. No, we had only 10 the element 10 in the S, and then we are updating it with these values as well. and we are adding through a list. You see a list because we cannot add the set directly. Set is like we cannot add the set directly, so we are making it as, if we have to make a list a set, we have to mention set as dot set function. But here we are adding, updating, so we are directly updating into the set this list as a set. So AJR is added to 10. Okay. Now I want to take two sets and make a union of it. You must, in mathematics, those who have taken up mathematics or knows a little bit of mathematics, they would know about sets, union of set, intersection of set, difference of sets. We can perform these functions in Python as well. So set one, let's take two set one, I will take, suppose, say, give this one, 1, 2, 3, 4. Okay. Then I will give set 2, 2, 8, 9, 10, 11. Okay. And now, or also I will give one, add one another element. Let's say 4. 4 I'm adding. Okay. So now what will I do? Set 1 union. I will just dot union. Union is a function in set. I'll just add set 2. Okay. And see what it returns me. Look, it is giving me the union. 4 is the common element, so 4 is only one times, and others are not common, so they are also there. Okay. So that's all about sets. Now moving into Python operators. So Python operators, there are many kinds of operators in Python. There are arithmetic operators, assignment operator, comparison operator, logical operators, and identity operators. So what are arithmetic operators? So arithmetic means plus, minus, then okay, just a second. I'll just okay. Yeah, arithmetic means the mathematical operators like plus, minus, division, multiplication, exponential, modulus, all that. And another thing we have this double slash called float division in Python. Okay, so let's look into the arithmetic operators. So let's say x is equals to 3 and y is equals to 4, then plus will return me x plus y, that is 7. Print, I will write print of x plus y. Print of x plus y. 7. So plus is an operator. Then minus, let's say y minus x, and I will print it. Y is already given as 4 and x is already given as 3, so I'll print it. Just a second. Print y minus x. 1. 4 minus 3, 1. Okay. Now, let's show you division. So, y is equals to, say, 15 and x is equals to, say, 3. So, y by x will return me, okay, print y by x will return me 5. Okay, return me 5. So then modulus. What is modulus? Modulus is something like, I'll show you. X is equal to, say, 5 then y is equals to 2. So when I take x modulus y, so what will it return me? It returns me the remainder, okay, after division. Next, see, let's see, next, let's see another assignment of arithmetic operator, exponential. So let's say y. So I'll do 5 to the power 2. That is 5 squared. So I'll just write x double star y and I'll just print it. Okay, print it. Print x double star y. Okay. 25. 5 just 25. 5 to the power 2 is 25. Okay. Next, floor division. Floor division gives me the nearest whole number. It like rounds off to the nearest whole number. Okay, just let me see what it comes. Gives me 5, 15, 6, and y is equals to, after division, it rounds up to the nearest whole number. So 2, and then we will get x, floor division, print x, floor division, y. This one, 7. Okay. 7.5 it comes, so it is giving me 7. Okay, so this was the arithmetic operator. Now we have other operators as well. Wait a bit. Yeah, so assignment operators. These are the assignment we assign anything, like x is equals to 2, so we are assigning 2 to x, and here we are adding plus assigning x, so we give plus equal, then minus equal, subtraction equal. So we do that assignment for assignment. Okay, so I will show you just in a quick example. First, in quick example, like x, let's say x equal to, I'll write 5, and then I'll write y equal to, say, 6, and I want to add it. So what will I do? X plus equal to it returns me actually a Boolean value. So let's say I'm saying x plus 3 equals to y. Okay, x plus 3 plus 3. Okay. Y equal to x plus 3, let's say. Y equal to x plus 3. Oh, sorry. Just a second. Just x is equals to 5, then I'll write x plus equal to 3. Okay. And print x. Let me see what it returns. So let's see what is happening. 8. So 5 plus 3, it returns me 8. So it is just adding the 3 to x. Okay. So since it is x is not a number, so we cannot add two number, like one is not a number and another is number together only through plus. We have to assign it with a equal sign. Okay, to perform the operation. So that was a quick example. And similarly, we can do for rest of the assignment operators along with this, along with this plus equal, then minus equal, it will work same way. Okay, then division equal, then modulus equal, floor division equal. It will just try it out at home. Okay, then there are comparison. We do the comparison, and then there is logical operators and identity operators. So we'll just look into comparison operators a little bit. Okay. So let's see how it works. I'm just giving quick example. You can explore the other operators uh, as well, but today I'm just explaining a little bit about that. In details, you can explore the operators to see. It will return me false because 5 is not equal to 3. So x is 5, y is 3, and I'm saying print whether x is equal to y. That means whether x is equal to y. So I'm asking the Python operator and it is giving me false. Okay, so like that way. Now I wanted to show you some Python built-in functions. So for that, it was in my agenda today to show you some Python built-in functions. So for that, you need to visit the Python documentation. Python has a very nice documentation. Whenever you type python.org docs, it will give the documentation. So these are the built-in function from A to Z, all the built-in function available in Python. It is built in, the functions are already built in within the function, like Python. We don't need separate libraries for that. So it is like absolute. Okay, so what is the work of absolute? Let me show it quick. ABS means absolute. So let's do it. So there is complex number type as well in Python. So it is represented as J. I is in mathematics we write iota. Here we write J. Okay. So now absolute of 3J will return me the real number only. 3. Okay. So now if I write absolute of a negative number, absolute of a negative number we all know is positive. So 45 minus 45 would give me 45. Okay. And then there is enumerate function. Not all the built-in functions of Python are very important, but some are we use very regularly, like len. I have already shown you len. Then reverse, then round. Okay. Then sort it. We use this very much. Then if we have to mention if it's a tuple, then we can write tuple. Then yesterday I have used type function. So like that dict function, you can make a dictionary. So like that, there are many functions like we use very much, like enumerate. So enumerate, I'll show a very good example given here only of enumerate. Let me show you. Yeah, see. So this is seasons. Seasons are given as spring list. This is a list of seasons. Seasons are spring, summer, fall, winter. And we are enumerating the season. Enumerate means giving an index to the elements of our list. Okay. So the spring is assigned an index of 0, summer is assigned an index of 1, and fall is assigned a 2, and winter 3. Like that, we are enumerating the season. So this is the function of enumerate in Python. This is a built-in function, and while building function, define function and other things later on in Python, you will use this enumerate function a lot. Okay, so please explore this Python documentation of the built-in functions. Okay, so let's now move on to the loops. Okay, I'll just start with the loops. For loop. First is for loop. Okay, so for loop, I'll write, say, I'll giving list equal to a list equal to, say, I like anything. I like mangoes. I'm assigning any random values. I like mangoes. Okay. So I want to print all the elements of list one by one. So what would I do for I in list I'll give a column. Okay, while writing a loop in Python, we use a column sign. Print I. So let me see what it returns me. I like mangoes, line by line. Okay, element by element. It is returning me. So like that, it's a quick example of for. Also, we can give like for index, we can also write like that index for each index give me the same thing. Like list is already defined, so I'll not write it again. I'll just write for list, for index in range of length of list, means length of list. Okay, what is the length of list here? 3. So length of list, okay, length of list, length of list, print list, index. Okay. Let's see if it works or not. Print list index. I think it's something is wrong. But, oh, I have not get to this one. Sorry. Yeah. So it is giving me I like mango. Same thing I'm getting. So parenthesis list index. Okay. So let's see now. This is the for loop. Next we have if else loop. So how to write the if else loop? Okay. So let's see that. If x, let's say I am assigning x is equals to say 10. Then I'm saying that if x is greater than or equal to 5, then print x is valid. That's why I'm writing this one. I want to print it. I'll just see what it returns. So it will return me x is valid because x is 10 is greater than 5. So it is if. Or now I want to write else. If then else print else print x is invalid, and I am let's say I am saying can access 4. Okay, now let's see what it returns. X is invalid because x is 4 and it's less than 5. It's not greater than 5. So since it's not, the if function is not holding true, it is printing the else function. So this is if else. Okay, if else for loop. Then while loop, we can write a while loop. So let's write a while loop quickly. I'll write a while loop. So while just a second. While first let me assign a variable count to 0. Okay, then I will write while count is less than 3. Okay, while count is less than 3, then write count equal to count plus 1. I will add 0 plus 1. Okay, count plus 1. While the count variable is less than 3, I'll add count plus 1. I'll add 1 to the count. Okay, and then I will print count is 1. Okay, count is 1, count is 1, count is 1. So count is less than 3. So first of all, it is seeing for 1, then 2, then 3. So it is seeing 3 times and giving me this results. Okay, so this is the while function. So next I will write say I'll write while else function. Let's say while else. Okay, so I'll write a list. Say I'll write a list equal to apple, banana, anything. Apple, banana, mango. Okay, now I will do one thing. I will create an iteration. So iteration of objects. Okay, object iteration of list. This is the variable name, object iteration of list. So I will write while true try root try list equal to fruit equal to next iteration object and then print fruit. Okay. Let's see if it gives. I think it will give some error. Yeah. Okay. Or iteration. I have written iteration. Stop iteration. Okay. Except stop iteration. I will write another thing. Except while true try put in brackets, and then I'll write except stop iteration. And then I will break the loop. Let's see what it gives. Yeah, so it is giving me apple, banana, mango through all the iterations. Okay, so that's it for loops. Now I'll move on to quickly to the machine learning. Presentation. Yeah, so let me set up the slide. Sorry. So, yeah. So this is the introductory workshop of machine learning. So I'll give a quick machine learning primer. So what is machine learning? Machine learning is the use of data and algorithms which is fed into a machine to imitate the decision-making power of humans. So what do you mean by the decision-making power of humans? We can differentiate if I take give one image of a cat and another image of a dog in front of you, you can easily distinguish which is a cat and which is a dog. But can machine do that? Can machine classify it? So we have to do something. We have to make the machine learn so that it can classify. Like, how do we know which is a dog and which is a cat? Because we from early childhood we are knowing that the dog looks like this, dog has 2 ears, 4 legs, like that. So the cat looks like that. So in our brain it is captured and we automatically can classify. So similarly, when in machine learning we try to put the data and also give some algorithms, run some algorithms, so that the machine is able to capture the patterns in the data and predict or classify or do many other things in uh, which enables the human, which replaces the human decision making power. Okay, so that is the primary definitions of machine learning. Okay, so in machine learning is basically feeding the machines with data and tuning it so that the machine is able to learn patterns from the data. Next, so this is the whole life cycle of machine learning. First, in the step one, we collect data from various sources. Like we do surveys, we collect it from open source sometimes, we web scrape, we do many things. And then second step, we clean the data, because data is not always what we want it to be. Sometimes the data are not relevant. Like if I want to get the data of say your marks, and someone is writing no, I don't have any marks, so that is irrelevant data. So we have to clean this error of data and do many other, like also machine can't take the string data, so we have to convert it into numerical format. Machine always take numerical data, so that is also a task in data cleaning and feature engineering. We engineer the features, we transform the features, we convert it into from string data type to the numerical data type. So this is one thing. Then we choose the model for building. Uh, we choose the algorithm for building the model. So we try on different algorithms in the data and then select one correct ML algorithm. And after building the model and training it, we evaluate the model to see if the things that we have taught to the machine is also working when we give a data which is not in the machine, which is a different data from another source. So if it works or not, we see that. So that is evaluating the model. And after that, finally, we do model deployment. In model deployment, we deploy it in the cloud so that everyone can see it. Okay. The next, this is the TRIS MLQ whole life cycle of machine learning. Okay. So in machine learning, there are 6 steps. First of all, when we get any problem, we understand the business and data understanding, and then we do engineering, data preparation, and then we build the model, and after that testing and evaluation, and after that deployment. That's all we have learned till now, but now another one is added, which is monitoring and maintenance. After deploying the model, we have to also monitor and maintain the model. if the model is working properly or not, if there is some problem, if the model has stopped working, or if the model is not performing as good as it was performing earlier. So we have to see all that things. Next, there are four kinds of machine learning. One is unsupervised machine learning, then it is semi-supervised machine learning, then supervised machine learning, and then reinforcement learning. So what is unsupervised machine learning? So unsupervised machine learning uses machine learning algorithms to analyze and cluster unlabeled data set. Unlabeled means, suppose we are having some data and we don't know what type of data it is. We have no idea. It is unlabeled. Okay, so this is unlabeled data set. And in unsupervised machine learning, we don't give that do like this. We don't instruct the machine. The machine does the thing automatically, and we just write the algorithms and all. Okay, and we need to understand how the machine works automatically, how the algorithms are working in the data. So this is unsupervised learning. So in unsupervised machine learning, the machine is able to discover similarities and differences in the data, and it makes an ideal solution for clustering based problems or customer segmentation problems. Then we can even do image and pattern recognition through unsupervised machine learning. Then there is supervised machine learning. Supervised machine learning has a lot of use cases in the industry. We use it to predict the prices of sales in the coming year. We predict it to detect whether there is a cancer tumor in the body or not. We do it for many kinds of problems. Okay, and it is a supervised machine learning algorithm. So the data sets are labeled. We know what kind of the data is, which column is what, and the classes are well defined. So we can execute the model. Okay, it is able to classify data or predict outcomes very accurately. We measure it. The machine is like, even human cannot sometimes predict the or classify with that much accuracy as the machine is able to do. So that is supervised machine learning. Then we'll come to semi-supervised machine learning. So semi-supervised machine learning is kind of a happy medium between the supervised and also unsupervised learning. So there is a whole lot of data, and only a small part of it is labeled, and the rest of it is unlabeled. So labeling takes a lot of time. You must have heard about data annotation. So labeling stands for that. Okay, in data annotation, there is a whole lot of money and time spent in like labeling the data. So in semi-supervised learning, only a small amount is labeled and others is unlabeled. So we have to use the smaller label data to guide the classification, and we have to extract the features from the larger unlabeled data set. Like in genes, we don't have all the labeled data. We have only some portion of it is labeled and others are unlabeled. So if we have to do gene classification, we have to use the semi-supervised learning algorithm. Then there is reinforcement machine learning. Today in the games that are built, reinforcement machine learning is very much used, and reinforcement machine learning is still in the research sector, but like it's still in research, but it over the last some years it has grown in very much in popularity. So it's a behavioral machine learning model. Okay, and it learns from the behavior the model has followed till now, the data that he has got and understand. He learns the mistake. The machine automatically learns what mistakes he had done and rectifies it. It is in reinforcement learning. So it goes by using trial and error method. It first tries and see if it gets an error or not. And after that, from the error, it learns to rectify it and then again tries. So it's a trial and error method, reinforcement learning. It comes under AI. Okay, so next. Okay, so that's it for today. Thank you.